All right, let's dive in. Today, we're pulling back the curtain on REST. Now, this is the secret language, the hidden engine that powers pretty much every app and website you use. By the end of this, you're going to understand exactly how it all works. So, let's get started.
I mean, really think about it for a second. How does your food delivery app know what's on the menu? How does your weather app get the forecast? They're all talking to each other, right? Constantly swapping information. Well, this entire complex dance is made possible by an architectural style called REST.
So, what is REST exactly? The first thing you got to know is that it's not some specific software or protocol. A much better way to think about it is as a blueprint, a set of design rules for building applications that need to talk to each other over a network in a way that's reliable and can handle massive scale.
Okay, let's break down the full name, representational state transfer. Sounds a little intimidating, right? But it's actually super descriptive once you get it. The key phrase here is a set of constraints. REST isn't telling you what to build, it's just giving you the rules of the road so that whatever you build plays nicely with everything else.
Here's a really simple way to remember it. Resource state transfer. A resource is just any piece of info. Think of your user profile. The state is what that profile looks like right now. Your current username, your picture, all that. And we transfer a representation, basically a snapshot of that state, usually in a format like JSON. See? You're just asking for a picture of the data. It's really that simple.
And these 6 principles, they are the absolute heart of REST. Take stateless, for example. It just means every single request has to contain all the information needed to understand it. The server doesn't remember anything from past conversations. And a uniform interface means everyone agrees to speak the same basic language. Following these rules is what makes a system RESTful.
Okay, so we've got the blueprint. Now, what about the tools? In the world of REST, our main tools are something called HTTP methods. You can think of these as the action verbs that we use to tell a server what we want to do.
A fantastic way to remember these is the acronym CRUD. It stands for Create, Read, Update, and Delete. And honestly, those 4 actions are the foundation of almost everything you do online. REST just gives us a specific verb for each one.
And this table just lays it all out perfectly. You want to read some data? Use GET. Simple. Need to create a new user profile? That's what POST is for. Now, if you want to update that profile, you've got 2 options. Put replaces the entire thing, while patch is for smaller partial changes, like just updating an email. And you guessed it, to get rid of something, you use delete. It's just so intuitive once you see it laid out.
So we have our action verbs. Great. But any good language needs grammar, right? We need rules to make sure our conversations are reliable, especially when things go wrong. And in the real world, things always go wrong.
Come on, we've all done this. The internet is slow, you get impatient, and you spam that place order button. Then that moment of panic hits. Oh no, did I just buy 2 of them? Well, this exact problem is why a concept called idempotency is so important. Idempotency is basically a safety net. It's a guarantee that doing the same thing over and over and over again will have the exact same result as doing it just once. It is the ultimate defense against the accidental double-click.
The absolute easiest way to think about this is the phrase repeat safe. If an action is safe to repeat without causing unintended side effects, well then, it's idempotent.
So which of our verbs are repeat safe? Well, get is, right? Asking for the same information twice doesn't change it. Delete is too. Once it's gone, it's gone. Firing delete again won't change anything. And put is also idempotent because you're replacing the whole thing with the same data. But post is absolutely not. Think about it. Clicking create a new post twice should give you 2 new posts, not 1. That's why it's not repeat safe.
Okay, so we send a request. How does the server tell us what happened? It sends back something called a status code. And a really good way to think about these is as response colors, kind of like traffic lights for our API requests.
It's actually pretty simple. Anything in the 200s is a green light. Success. It all worked. Codes in the 400s mean you made a mistake. The client, that's you, sent a bad request. The classic one is a 404 not found. You probably typed the URL wrong. But codes in the 500s, that means we made a mistake. The server messed up. This simple system makes figuring out what went wrong so much easier. Let's get into one of the coolest, most powerful ideas in REST, discoverability. How do you build an API that's smart enough to actually guide the user, to show them what they can do next? So let's use the memory hook API links.
Imagine this. What if you asked for a user's profile, and the response you got back didn't just have their name and email, but also included ready-to-use links for other actions, like a link to Update Profile or View All Orders?
Well, that's the whole idea behind HATEOAS. And yeah, I know it's a ridiculous name. It stands for Hypermedia as the engine of application state. But don't let the name throw you. The concept is genius. Instead of just getting raw data back, you get data plus links that show you where to go next. This makes the API self-discoverable, almost like a website for machines.
So we've covered all these different concepts. How do we put it all together and figure out how RESTful an API actually is? Well, believe it or not, there's a grading system for exactly that.
And we can use the memory hook REST levels to frame this. There's a framework called the Richardson maturity model, and it's just a simple way to grade an API's design on a scale from 0 to 3.
There are 4 levels. Level 0 is basically just chaos, using the web to shout commands back and forth. Level 1 starts to bring some order by defining distinct resources. Level 2 is where most APIs today live. They correctly use all those HTTP verbs we talked about. But level 3, that's the pinnacle. That's the glory of REST. That's an API that uses HATEOAS to be completely self-guiding.
And really, that's the key takeaway here. This model isn't about passing a test. It's a roadmap. It's a guide to building better, more intuitive, more resilient systems that truly live up to the vision of REST.
So, there you have it. We went from a simple question, how do apps talk, all the way to a full architectural blueprint. Now you have the rules, the verbs, and the framework. So the only question left is, what are you going to build? The possibilities are pretty much endless.